Okay, so next topic is Markov chain. This is one of the basic principles that most of the text-related problems are depends on. I mean, the logic behind for most of the text problems is going to be this one, Markov chain principle. Even though it's been mentioned as Markov chain, actually a principle. So we need to understand the logic behind this. So the idea is, I have taken a data set, and this particular case, I have taken one document, that is one row of data. This is what it is, a huge amount of data, right? And in this, what I did is, like, we have taken every word. Let's, for example, in a simple sentence. So this is generative AI course, right? So I'm going to take this. So it's going to loop every word, okay? And then is, and then generative, and AI, then quotes. For every word, I'm going to prepare a list. Basically, a key dictionary. Okay, so this list is going to have the next word that it got occurred. So that after this, what is the next word here? It is these is, right? So I'm not wrapping it in. We have to mention single quotes as a string. I'm ignoring it for now. So we need to mention is. So the what is after is, it is generative. So what is after generative? It is AI. So what is after AI? It is course, because we don't have anything after course. We're going to stop here. This for a simple sentence. Let's take that. We're going to take a full sentence. Right? Let's do the same thing for this one. Okay, so that's okay. The same word, isn't it? So there's a difference. Let's consider that. Okay, just consider that we have cleaned this data. That's shit. You do, right? In your quantities. Okay. And when in you are in, let's consider that you or your solve the same. That is, and you, I think you already been mentioned, right? So we are like not this one. Just consider that we have cleaned it, and yeah, I don't have this have. So I have taken few words. So we need to take for every word, and we need to prepare the list. So what is actually that's after that we got, okay, ignore that same word. We got shit, right? Same way, is there any other place where we have this that's we don't have anything here. All right, so we'll stick to that. So do we have anything, any other word after shit? So we have you, and is there any other place where we have this word shit? We don't have. All right, at least in this particular sentence, paragraph. So you have do. The next word is do. So is there any other place where we have this you? Yeah, here just consider that it's been clean. So we have in. So again we have been. Any other place? Yeah, you have P. Again you have when. As you again when, right? When being repeated twice. Yeah, that's all. So when being repeated twice. So just consider that this is two. The P has been repeated only once. So Bean is going to has been repeated once. Same way for in and into. So when do it for all the words. So when we generate, let's take that you want to generate some text. Okay, that is you. So you have given this input. This has input, and the system need to generate text after that. Okay. Then in this case, in you, what is the most frequent word that we got? It is when, right? CU is going to generate when. So we will have when also here. So what is, it will have its own list, isn't it? So when we have in, and we have you again. You, do we have anything else? When again, it, we have it here. And yeah, again it. So it has been repeated twice. Whereas the remaining are one and you, in and you are once. So it's going to say it. Okay. So what is, we have it here, right? Somewhere. Don't have it. Okay, I have not written it. So again, we will have it. For every word, we need to write it. I have written only for few words. I hope you got the point. So basically, we need to prepare the list, and the most frequent word we can place it here, so that it is going to generate some. Let's take that I want uh, generate text uh, like no, of 100 words. Okay, then we have given this as input. From here onwards is going to keep on adding the words based on this list and based on like most frequent one, most frequently occurred word based on the corpus that we have given. So it's not just for one no document. We need to find that for multiple documents. So based on this, there are a lot of problems that you know being solved in NLP, natural language processing. In fact, the most like let's say text generation or text summarization, right? The question answering, these sort of things can be answered now is based on this principle. Any questions on this? You can see that every word we have generated list and we have gentlemen foremost then have. So when we give some sentence, so this basically takes some generate text. It's going to keep on randomly pick the word. Here I have taken the random choice. Random choice in the sense is not based on frequency, but randomly it's going to pick a certain word in this list. And it's going to keep on adding it. So we got what want, and it's going to randomly pick from want list, right? Let's consider that we have want list here. So it's going to randomly pick certain words like word one, word two, word two, three. We have taken the logic been written in like a random choice, but we can even write it like most frequent one. So logic here may change, but the principle is the same thing. We got as Markov chain principle. Any questions on this? How this text generation works and how text summarization even works?
No, sir.
But next one is, like as I told you yesterday, that whenever you see these downloads, it is for the first time. I already executed this once. I don't require it. I commented this part. Okay. Anyone try the yesterday script download part? Is it working?
No, sir. I haven't.
You haven't tried it or you haven't got any errors? What do you mean?
No, I haven't tried.
Okay. So it is whenever you see this like any new word being anything that has to be downloaded for first time, you have to make sure that it is uncommented. Okay. In my case, I commented because I already downloaded it. And for it is only for the first time. So the next time onwards, you don't require it in the same mission. All right. So the next one again, we need to install few things here. So Spacey and this one. And we need these libraries. Already installed it, so I don't require to this one. So I'll comment this part. In your case, you need to install it once. All right. So next one is we are going to see the NLP basics, natural language processing basis, how we can clean the data with various methods we have. Mostly you're going to use NLTK library, natural language toolkit, we call it as. And there are a few other libraries too, like Spacey, right? Text block, Spacey and text block. So it's your choice, like whichever you feel comfortable, you can choose, you can use that. And few like there are additional libraries like Enchant, Ola, wherever it is required. I am. We'll see that one by one. So how to replace data? I think we have to start regular expressions even before NLP basics. I think I forgot that one. Okay, let's start regular expressions first. So regular expressions, we have a dedicated specific library for it, specifically for regular expressions. You can see RE library, right? When it comes to sentiment analysis, I'm looking for. How do we use this RE library? So we're going to build a pipeline, something like you can see that RE library being used, right? Sub is basically to replace. We will see methods that RE supports. You can see we can clean this data. And finally, we're going to feed to the model. So this is what we call it as pipeline. So whenever input, it's not just generating model. After we got the model, we need to clean the data and present the data in a format that this model has been tried. So only then this predict will work. So we have applied TF-IDF, right, in the classification problem. We applied the same thing. Anyway, that's not the point. The point is that how we are going to use in real time the tree library. Regular expressions is going to support a few methods like match, search, find all, and serve. Split is basically to split the data. Let me start with this library. Usually we don't require any additional installation, but if you get any error like no module name RE, you open terminal and install pip install RE. Okay, so we are going to use split. Split is not basically, of course it's a method, but it's not for regular expressions as such, right? So let's consider that this is the data that we have. If you observe it closely, we have multiple separators here, comma. Usually, we will have only one common separator, right? Here we have comma, semicolon, we have even space separator. We want to split this string into multiple words. That list is going to has to have 1, 2, 3, 4, and 5 strings like this. We can use the regular one. The problem is that we have to give only one set of separator, either a comma or semicolon or space. So in this case, it doesn't work. But when it comes to relibrary, we can use
Hello?
Narendra, you can hear me?
Yeah, maybe some problem is there at the search and I think.
Oh, okay.
Yeah.
Maybe I thought that it is my problem.
I just left the meeting. Yeah, we'll come back.
Network. The network got disconnected and connected to mobile network. It may be slow. If you feel any voice breaks, if you see frequent disconnections, let me know. I'll continue tomorrow. Right now, I'm using mobile network. Right.
Okay, sir.
All right. So, okay, when it got disconnected,
Regular expression you're telling.
yeah, regular expression. Did I complete this one?
No, we
No,
are
no, no.
different
Not this one.
separators are there. We are
Yeah.
discussing.
So here split. So the regular one we can provide only one separator, whereas in RE split, RE library, we have method called split, wherein we can provide a list of separators. You can see that here we have comma, semicolon, and even space. There are three separators, right? If we have more, you can provide more separators. In this case, you got list of words, which is not possible with the traditional Python way of splitting the data. From here onwards, the actual regular expressions starts. This is just a method. Here, the match we are not going to use it much, but we'll see that most of time we'll use find all. But we need to see we'll see an example on match too. So let's consider that this is the data that we have. Okay, so we need to match. Suppose if we give a keyword called Modi, it's going to check the particular document, or let's say sentence. It's going to check whether it starts from this word or not. Match is not going to search anywhere in between. So it's going to search only at the start. For example, let's take this one. We got Modi because it starts from Modi. Let's consider that I have given space. It's going to throw error because this returns none. So when this returns none, then there is no group method on none. So that is what this is trying to say. So if we don't use this group, for example, let's take, we're not going to get the output. So we need to use group. For example, let me check it. Or even there is, if we can see that there are few other words, Modi, been occurred, right? You're not going to get that. So match is going to search only whether this particular keyword, whatever we provide, going to start with that or not. That's all. Search is going to search anywhere in between too. But the problem is that it is not going to search the whole thing. So it's going to search only the first. It's going to get us the first occurrence of it. For example, let's take. Right here we have. You can see that okay, so it's Modi. Right, so we got the Modi. For example, let's take that I have given space. Will that work? Yeah, still working. So even if it is somewhere in between, it's going to work. Let me remove this word completely. It still works because it is somewhere here, right? If there is any slight change in it, will it work? Yes, it is still working because there is a word here, even though it's not complete one. So search is going to search anywhere in between, but it's going to search the first occurrence of it. Suppose if we have another occurrence of it, it's not going to search that particular thing. It's not going to return anything, return that particular part, right? Or the next one is find all. So find all is going to be, we're going to use this quite frequently. It's going to give us all the occurrence of it. For example, here we have prime here, and we have another prime here, maybe like two occurrence of it. So you can see that find all, when we give prime, it is going to give us all the occurrence of it. You can see that, right? Prime, prime. But here, what I did is, like I mentioned lower. I'm searching lower. So this is going to convert prime into small prime, like even this is going to convert. So if it is like prime, then if we don't mention, if we simply mention like this, if we don't mention this lower, then it's not going to return this one. So whenever you are trying to clean the text data, or pre-process the data, always convert into small case. Otherwise, unnecessary duplicates will be, will fill up the whole data set. So the prime frame, we got two occurrences of it. Of course, we can loop it and we can pre-process. But find all is quite quite frequent. We are going to use that. The sub is basically to replace something. So we have seen replace, right, in Python 1. The same way we have sub means substitute. Substitute is nothing but another word for another synonym for replace. So when we give Modi, and if we want to replace Modi with Amit Shah, so we can replace all the occurrence of it. You can see that it got replaced. So wherever there is a word called Modi, is going to replace with Amit Shah. And we have to provide this one. Yeah, so these are methods that reliability supports. We will get into the regular expressions now. So here I have mentioned the list of regular expressions, right? So this list is more than enough. Not to learn anything. I mean, not learn anything beyond this. So if you learn these regular expressions well, then it is more than enough. Most of the time, you're going to use these sort of these expressions. Even if you look at this sentiment analysis, most of the one that we have here, it comes from the same list. So the regular expression, in fact, it's a huge language altogether. Okay, so basically the idea is to understand, to get the data by providing the pattern. So it is not possible to extract data by keep on hard coding it, right? So we need to provide the pattern so that we can extract something that matches with that pattern. So that is when this regular expression is required. For example, let's start with this one, this hard code value. What I mean hard code in this hard code means, for example, if you have text data, if I mention the min, so it's going to search for the min here. You can see that min here, right? So it's going to return whether it is there or not. If we don't use group, it's going to give us some sort of information apart from what it matches. It is going to give us the starting index and the ending index, 18 and 21, 18, 19, 20, 21. So outer mode is not going to get included. Okay. So it's hard code. So we have given the literal keyword here. There is no pattern, in fact. Of course, that is also acceptable in real library. Here, for example, again, another hard coded value. I mean to say the 14 I have given. Here we have 14. So we got 14 here. The next one here, the actual pattern, regular expression pattern starts. Slash small d, again, case sensitive. Slash small d means all the numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Either we can provide a list of 0 to 9s. I mean, it's the same as this slash d. There's no difference. We can provide 0 to 9. Let me execute this slash d first. We got all the numbers in this list, right? Or else we can even provide this list. Okay, there's no difference, but it's better to provide slash t. The reason why I have provided plus is if I don't mention plus, then it's going to search like it's going to be like this. So we got 1. So it's going to check only the first occurrence of it. I mean, say it's going to extract, it's going to find out the first occurrence. So we got 1. But find all is going to check all the occurrences, right? So we got 1, we got 1 here. And then it's going to check again. 4, 4. And then it's going to be 1, 1, 4, 4. Again, 2, 1, 3, 4. But that is not what we may expect. So we may expect that this regular expression has to expand till it finds a non-number. So the 1, 4. So t is non-number, right? So it's going to stop. Let me plus. It has to be expanded. So we got 1, 4. But find all is going to kind of a loop, right? It's going to check every word. It's going to keep moving. And then it's going to got 14. and then it's going to keep moving. So it's 2, 1, 3, 4. So at the end, we extracted all the numbers that this particular document or corpus has. Okay. The next one is, again, it's, as I told you that regular expressions are case sensitive. Small d is totally different from capital D. Whenever you see this combination, small d and capital D, it is exactly opposite way. So when we say small d is any number, any digit, capital D is going to be non-digits. Now, what are the non-digit values we have? Alphabets and special characters, right? Do we have anything else? It's only uh, alphabets and special characters. In this case, when we mention capital D, it is going to extract everything except numbers. You can see that it got up to here, it encountered number, so it just stopped here. But find all is going to check every other, it's going to kind of loop, right? It's going to check for the whole corpus. So it's going to start again from here till here. It encountered number, it's going to stop here. And we got this one, right? The first part, mode is so we got as the first value. Again, it's going to keep moving and it's going to stop here. So we got this part. So we got 3 and we can combine it together, right? We can use list comprehension. We can strip some trial space, whatever we have, and then we can add all together. So finally, what we got is, it doesn't contain any numbers. It may have special characters, right? Or it doesn't contain any numbers. It's been cleaned. The next one is any character. Dot here is basically means dot. Dot means any character. Here doesn't make any sense, but I have another example. Dot means any character. So it's going to give the complete text. So whatever we have here is going to give the complete text. Here, this is not the right example, but we have another example somewhere here. Dot asterisk. Search for dot asterisk. Here you can see dot asterisk, right? So basically this means cap means any letter that comes after cap. So it has to start with. So it's going to search for the whole corpus in a way that it is going to search for the word that starts with D. But it can be anything in between. So dot means what? Any character. And asterisk means 0 or more occurrences. So this is going to work for this one. Even if there are no words for it, still going to work. But if you mention plus, the problem is that dot means any character. It expects at least one character, one or more occurrences. This is not going to work. At least it has to have one character. At least a space is going to work. But plus is now going to demand at least one character as such. So dot means any character. So it doesn't matter how many what character it is. At least it has to be one character. Apart from it starts with D and ends with F. So whenever you want to mention, it has to end with F. So end with some character. We need to mention dollar. So in any character that is before dollar, it has to end with. After cap, it has to start with. Okay. So here, I want to go with dot asterisk. Dot means any character. Asterisk means 0 characters. In this case, it is going to work for DF space DF, D space F is going to work for EF, E whatever. So it's going to work in all the cases. This is when we use this dot. Even though here it doesn't make much sense, but I have to give an example. So that's the reason I given this dot. Any character. But if you want to check, for example, by default, it is dot means any character, right? But if you want to check even the dot or any special character, in some cases, the dot, any special characters in Python, it will have its own interpretation. Here it means dot means any character, but I want to check as it is. Then I need to use special escape character. Where is that? So when I mention slash, escape character we call it as. So immediately after that, any character been encountered, it is going to interpret as it is, not the usual way the Python interprets. The usual way the Python interpret is any character, right? Or let's take that we have something called hash. Suppose if I mention maybe I can say asterisk, okay? So since we got Mr., but if I want to get even the asterisk part, use escape character, then whatever the special character it is, uh, present as it is. Don't look for the usual way of Python interpretation. You can see we got Mr. asterisk. That is how this escape character works. In
Sir,
this case,
capital D we cannot use, sir. Just now you have told that other than numeric anything it will become.
yeah, so the thing is that Python is case sensitive. So it's better to whenever you clean the data, convert into lawyer. Unnecessary duplicates will we can get rid of. Is that the question that you have asked? Voice was not clear.
Yes, sir. That is sir.
Yeah, so we need to convert into lawyer. So here I have not mentioned it because that's not necessary. But yesterday in text classification, I have converted into lawyer first, right? And then I have operator split. Remove special characters and operator split. Okay, the next one is yeah, basically whenever you provide it in the list, it means suppose I have given ADC, it means A or D or C. It's going to extract ADC. So it's going to ignore the remaining space or O or R, all other characters. It's going to extract only those values. Okay. So A or D or C. Suppose if I have mentioned B, A or B or C, that is what it means. Here is another example. So A, B, C, it's going to give us the first occurrence, right? Or such. Find all, but find all does not require proof. So we got A, C. We don't have B, so we haven't got it. Right? So, and when we mention cap and certain letters, it means not. So don't look for these values. Suppose if I have given, in this case, ADC, and given not, then it's going to, anything that is not A or not B, not D or not C. Then what do we have here? We have space, O and R, right? Space, O, R, space. Space, O, R, space. That is what we got. Not.
Sir, it's not audible.
The last,
Disturbance was there.
because internet connection. Okay,
Yeah.
my point is that, okay, you got this point, right? Not
Yeah,
A or not B
starting
or
with
not
A.
C.
Yeah.
All right. So not A or not B or not C. That is what this means. So it's not anything that is not A or not B or not C, we are going to get it. Suppose A, B, C, D, E. Anything not A, not B, not C. What do we have here? D, right? We got DA. Whereas in this case, it is not A, not B, not C. So we're going to get DE. But don't get confused with this one. I have given another example, right? Or feed, you can say DF. So this
Yes.
is different. When we provide in the list, then it is not. But when you provide within just a single quotes or double quotes, it has to start with this character. Okay, there is a difference. And definitely it requires practice to understand the difference. Initially, there's a possibility that you get confused. Okay, the next one is whenever you mention A to Z, it means all the alphabets, but it is small case. small a, small b, small c kind of. When you mention capital A to G, it means all the capital uppercase alphabets. Capital A, capital B, capital C, capital up to capital Z. So this doesn't mean just A and G. It means all the capital uppercase alphabets, all the small case alphabets, and here I have mentioned space, and all the numbers. 0 to 9 means all the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, what do we get is anything that is not special character. For example, I've given, okay, I'm going to get, here search is going to stop right here itself. That's the reason it got stopped. Do we have anything else? Why it got stopped? Yeah, because this dot is a special character. It got stopped right here. So if we use find all, we're going to get all the occurrence of it. You can see that we got everything. We haven't got dollar because it got cut off right here. Minister off. For example, if I get rid of this, you can see that it got expanded, right? So it's going to remove all the special characters. That is what it is going to do. In some case, I have given both search and find all, but find all, better use find all because it's going to give all the occurrence, whereas search is going to give only the first occurrence. 0 to 9, we already saw an example right here itself, all the numbers. Either you can use slash small d or within square brackets 0 to 9. So all the numbers. You can use either of this method. Better to use slash d. So in the same case, if I use slash d, it's going to work still. If I use find all, and find all does not require group, it's going to give us all the occurrence of it. Slash small w is basically means alphanumeric. Alpha means all the alphabets, and numeric means all the numbers. What do we have? What else we have apart from alpha and alphabets and numbers? The only thing is special characters, isn't it? So it's not going to consider special characters. We can even use slash small d to get rid of special characters. In this case, I have used find all. It is going to extract all the alphabets, okay, and numbers. It does not include any special character. It does not include spaces. You can see we got all the list of words that has either alphabet or a number. It does not contain any special characters. But there is an alternative for small d, small w. The alternative is if I use capital W, which is exactly opposite to small w. So what is small w? It is alphanumeric. Exactly opposite means non-alphanumeric. What are we going to have in non-alphanumeric? It is not alphabets, it's not
Special
numbers, special characters, obviously. That includes dot, space, whatever it is. Okay. Here I should not have this example. So here we have this is the example. You can see it's going to extract all the special characters. You can see dollar, space, dot, period, space. You can see that, right? Sorry. The next one is number of repetitions. For example, you want to search the date like this, right? It has to be in this format. Okay. For example, either it has to be two set of numbers, two set of numbers, and four set of numbers. Then this number within curly brackets, if I mention 2, it is going to search the whole corpus in a way that it has to be 2 characters dash. This can be this hard coded. It can be anything, right? If I mention something else here, let's take plus. I can mention plus here. So this hard coded. There is no specific meaning for this. So this slash number, two numbers, and 4 numbers. What do we have here? We got this one. So up to here, you can see that. Okay. But we can even mention the range of values. For example, in this case, month can be even one number, right? So how do we do that? So this is not going to work. So you can see that we are not going to get this value. In such case, what we can do is 1, 2. It means it can be one occurrence or two occurrences. Then you're going to get this even in this case. So let's consider that we have given 0 also. And we got even. It's going to work in both the cases. 1 or 2. Suppose if you want to mention 0 occurrence of also, 0 occurrence of it, then you can use 0, 2. For example, I have completely get rid of it. I'm still going to fetch the data. But if you mention 1, then it's going to fetch this. Again, we need to give and cap small m to n. I mentioned, I give an example right here itself, even for this one. Asterisk means 0 or more repetitions. We have already saw the example in this def case, right? In this case itself, how this asterisk is going to be helpful. So either 0 or more. Here I have mentioned dot means any character. It has to start with, of course, D and end with F. It can be 0 or occurrence, in the sense it can be any character with 0 occurrences. It can be, it's going to work even in this case without anything in between D and F. It's going to work. If there is a space, it's going to work, or it can be any character, it's going to work. Right?
Sir, not audible.
But when we mention plus, it is one or more occur. Even if there is space, that's fine, because I mentioned that plus means one space, so plus is going to work because it is expects at least one character. Whereas in such case, we better use asterisk. That's the idea of asterisk here.
Sir, can you please repeat that one, sir? There was some problem with the voice there.
Okay, I'm saying that already I explained this example already. I mean, this one asterisk means 0 or more occurrences. Even in this case, this is going to work because dot is any character. It can be anything in between D and F because it starts with D and ends with F. I'm saying that it can be any character. It can be blank, it can be space, it's still going to work. Whereas when we use plus, it expects
At least one should be there. Correct, right?
at least one character. So at least one occurrences. It's not going to work, and in this case, it's going to work because I given space. Even dot is going to consider any character, right?
Yeah, got it.
Next one is question mark. Question mark is like when you want to it's optional.
Sir, there is too much lag.
For
Your voice is completely breaking.
Wherein I want to mention, I want to make this SS op that is going to be optional before question mark is, for example, in this case, we have corpus here. Yes, it is going to
Sir, we can't hear you.
1 second. Stop. I'm not speaking. Wait. Okay, so I'm saying that question mark, whatever optional. What I mean to say, for example, in this case, we have corpus, right? Even in this case, this will work. Even if you mention emissions, this is going to work. Even if you mention dot, I mentioned another optional character here. Whatever the character that we mentioned before question mark, it is optional. Either it can be or it cannot be there. So in this case, it is going to work for Mr., Mrs., even from Mr. Dot or Mrs. Dot. Clear?
So first question mark is what is the purpose of first question mark?
So it doesn't matter how many question marks. It's just like you can use many times, n number of times. The point is this is optional character. So whenever you use question mark, the character that you mentioned before question mark is going to be optional. Here I mentioned two optional characters, yes and dot. So in this case, it's going to work for Mr. You got Mr. Dot, because S is optional, right? Mrs. Dot or even without dot. I've given two optional characters, yes and dot.
What if that dot was in the middle of the sentence anywhere? Like it will
Here?
consider till that part.
Here?
No, somewhere in the middle of the sentence itself. After Narendra Modi.
No, this has to be there. So Mr. has to be there. So I've given hard coded here. Not anywhere like something like this. So this is Mr. should be there. Thereafter, the characters that we mentioned all should be optional. We made it as optional. Clear?
Yes, sir, got it.
All right, this next one is space. Suppose slash small s means one space. I think we already saw this example in pandas. While reading files, in pandas, while read underscore CSV, I have mentioned separator as slash s plus. Refer back the pandas. Basically, slash s small s means space, one space. Suppose if I mention this one, of course, we can use plus, right, to extend it. We're going to get this one. Suppose if we don't mention this, what will happen is it's not going to work because there is a lot of space here. Of course, we can clean that part, but just consider that we want to fetch this sort of data too. Then we can use not just one slash s. One slash s means one space only. It's not going to work. We need to mention plus to extend it to any number of spaces in between Mr. and Narendra. Then we're going to get, doesn't matter how many spaces, it's still going to work. Right? Slash capital S is exactly opposite to small s. So slash small s means space, whereas capital S is non-white space. So what does that mean? Any character that is not white space. For example, if I give find all, maybe this is the best option. Less, it is going to extract everything except space. So it's going to be, this is going to be the first word, and this is going to be second word and third word and so on and so forth. What do we get here? It is very much like split, right? At least in split, what happens is it is going to, I think, yeah, so split, right? Because it's going to extract anything that is not space. This one, we already saw that. So cap means any character that followed by cap, and dollar means any character that is before we have, right? This we have seen it 2 to 3 times. Okay, so it got disconnected, I think, for a while. So like, have you listened this slash capital S?
Yes, sir, about the space, right?
Yeah, the non-white space. Small s is white space. Capital S is non-white space. Non-white space means what do we have here? All the alphabets, all the numbers, all the special characters. Even dash is special character, right? It's going to get extract everything except space. We can use it like, split.
Yeah.
Alternative in capital S. So there's a possibility that you may write a wrong one. Okay, 1 second. Okay, so this one, we already saw an example, starts with any character that is after this cap starts with, and any character that is before dollar ends with. Okay. So I don't want to explain it because we have repeated this 2 to 3 times. And this is capture group. Capture group means there is a possibility that we can extract multiple groups. You can see that we got one group and another group. If you want in that way, we can use that one. So it has wrapped in round brackets. You can see the round bracket here. This is one group and another group. And it's better to use one group itself with the find all. That's going to work rather than using this one. In this case, it doesn't make much sense, but we can extract it in that way too. So here what I did is numbers, at least 4 characters, or non-alphanumeric, that is special characters, right? So it's going to extract numbers because it is not giving any results. That's the reason we got this one. In this case, it's going to keep on looping for every word, right? Even that includes space. So it has not got anything in this particular group, in this particular word. And the next one is Mr. Again, it has not got anything. It has not matched this one. And it's going to give us space, right? This whole thing is a one character. And again, the Narendra Modi, we haven't got anything. But when it comes to this one, 2019, because it's 4 characters, right? It's not going to work for this one. So 2019, we immediately got this one. So there is a way that we can give multiple set of results, like multiple subsets. But I request not to use it unless it is necessary. We don't, practically I don't use it much, but there is a possibility that we can extract subsets. It's better to use one group and use it multiple times. I mean to say, if we want to extract special characters, use it another time. So after doing this, use this as an input and then apply / small capital W, because it is again difficult to extract each subset, right? And the last one is this hard-coded again, either this or that or symbol. Here what I mean ABCDEF means either this or that. So 2019 or 2018, 2020, both are going to work. Or let's take that 18 here, right? I have given 18. It's going to work 18 or 20. For example, I have given 20 here. Now it's going to work. Here I have used search. If I use find all, it's going to give us all the occurrence of it.
In search, it will search for the first occurrence only, right?
First occurrence. Better use find all. Later on, if you need only the first occurrence of it, then you can use anyway this one, right? You can get this one. Okay, so this is about regular expressions. Tomorrow we will see another project on it. So we have discussed Markov chain principle. This is the basis, the basic principle that most of the natural language processing problems rely on. And the next one is regular expressions. Tomorrow we may see sentiment analysis. Yeah, sorry for that. I mean to say the network issues that we faced. I'm using mobile network. I don't know the reason why the main broadband got disconnected. All right, we'll continue tomorrow.
Okay.
Okay, sir.